Hi friends, so this video is just going to be a couple of worked examples. So I'm actually going to ask that you start by pausing this video and trying these two problems to identify the domain and range and determine if it's a relation or a function, and decide if it's one-to-one or onto or both or neither. And then press play when you're ready and we'll see if we were thinking the same thing. Okay, great. So I'm assuming now that you have pressed play, and I'm going to take a look at this first one, and I'm going to first determine what the domain and the range are. Well, here it's pretty much just given already, so I'm just going to write out that the domain here is the set that includes 2 and 8, and the range is the set that includes 21, 25, and 30. Okay, so that's my domain and that's my range. Now I'm going to try to figure out if this is a function or not. So I'm going to take a look at my input values and make sure that each input maps to one output. And here in this very first instance, I notice that 2 is like a train on 2 tracks here. Sometimes 2 goes to 21 and sometimes 2 goes to 25. So that is not a function. Okay. So since it's not a function, I don't need to go on and determine if it's one-to-one, onto, both, or neither because it's not a function. Great, so I'll look at the second one. So again, the domain here is going to be the list, these discrete values. So -3, -1, 0, 2, and 3. I'm just going to list them. Here I'm sort of happy because they're listed in order from least to greatest, so I'm just going to keep them in that order. The range I'm going to take a look at, and I'm going to, because they're just a list of them, I'm just going to list them from the least value to the greatest value to keep my life organized. So it's -2, -1, 0. There's 2 zeros here, so I'm only going to list that once, and then 4. So that's my domain, and that's my range. So now I'm going to decide if it's a function or not. So I look at the x values, and there aren't any repetitions in my domain, so there's no opportunity for one x value to go to more than one y value. So this is a function. Okay. So since it's a function, we need to ask ourselves, is it a one-to-one function? Well, let's see. Does every x value go to one y value exclusively, right? Is it a monogamous relationship? Well, -3 goes to 0. But if I look down here, because remember I only listed that 0 once, there's somebody else hanging out with 0. So -3 is hanging out with 0, and 0 is hanging out with 0. So this is not a one-to-one relationship. Okay? Not a one-to-one relationship. Is it onto? So what does onto mean again? Oh yeah, onto means that all of the range values get used. There's no number in this list that doesn't show up in the relationship. And clearly that's true. In fact, one of the values got used twice. So it's not one-to-one, but it is onto. Okay, so it is an onto problem. Great. So one more example that I want to show you. I'm just going to switch the side. Want to pause it here, and I'll let you know, and then I'll go on. Okay, so I'm assuming that you have unpaused it now because you are looking to go on. And so we're going to graph this equation first and then determine the domain and range. So here I'm looking at this equation, x equals -1. So I'm going to find the x-axis. I'm going to find all the places in the universe where x is -1. Well, x is -1 there. It's also -1 there. It's -1 there. It's -1 all in between. So that is just the line, the vertical line here along -1. And I'll just label that as -1 so we know where that line is. So the domain, all of the possible x values are, well, x such that, well, the only possible x value is -1. So I could write it in set builder notation. I say I'm interested in all of the x's such that x is equal to -1. Or I could even just make a list here, because it's a list of one element, and just say that the domain is -1. The range, on the other hand, is going to be way more numbers, right? So it's going to go all the way up to, well, positive infinity, somewhere up here, and it's going to go all the way down to negative infinity. So the range is the set of y values from negative infinity all the way to positive infinity. Okay, or I might just want to say that it's the set of all real numbers, right? I might, to be really clear, I might say that y is an element of the set of all real numbers. Okay, so those are my domain and range. And check. Determine whether the relation is a function, one-to-one, onto, both, or neither. Okay. Well, let's try the vertical line test since this is a graph. So can I find any vertical line? Is there a vertical line that I can drop here that I can place that intersects my graph more than once? Well, it's kind of a trick question. Absolutely there's one. There's this vertical line intersects infinitely. It's the same vertical line. So it intersects infinite number of times. So it fails the vertical line test. So it is not a function. Therefore, it's not one-to-one, it's not onto, or because it's not a function. Okay. So we're going to state whether this is discrete or continuous. And so that's just asking, is it a series of dots or is it connected? And clearly this is a connected graph, so this is a continuous graph. We're interested in all the things in between and all the things sort of beyond. So that's my thinking for that. Thank you guys very much. I hope you enjoy the rest of your day.